Welcome to this afternoon's Art Fusion Experiment, live from Norwich University College of the Arts. My name is Derek Feynman, and I'm Operations Manager for the LHC. This is Higgs, my trusty assistant. All systems are stable, and all being well, in around 8 minutes we should all be witnessing history in the making. But first, let me explain to you the intentions of this experiment. What we hope to achieve is the positive identification of the theorized Daxma particle. Physicists believe that the Daxma particle is integral to evaluating the supposed value of an art body. The experimental detection of this particle would help scientists and curators explain how art can have a true artistic mass. Nuclear theory strongly suggests that if two large art bodies were to collide at great speed within a charged environment, a fusion would occur. This art fusion would create a residue of art matter and, strangely enough, anti-art matter. At this critical moment of collision, art particles would burst into existence, be detected, and have their pathways tracked until they finally became unstable and collapsed. Now to the question of safety. I would like to make you aware that due to the very close proximity of yourselves to the collision chamber, at the moment of impact you will feel some localized effects. If the collision is successful, then you can expect some noise and possibly a flash of light. This is entirely normal with this kind of experiment. You will also experience a rise in temperature within this area. This is also normal, and its cause is due to small increases in ambient low-level radiation. This, I can assure you, is entirely safe, as you will only be exposed once. If anyone here has observed this experiment before, please raise your hand now, as we have spare protective clothing for you to wear. You are all aware of this, as you have read and signed the disclaimer prior to entering this area. Okay, on to the experiment. What you see behind me is the collider itself. 5 days of intense work has gone into designing and manufacturing this machine. Here we can see the central component to the entire experiment, the collision chamber. This is cooled by liquid helium to a temperature of approximately 1.9 degrees Kelvin and is manufactured from 2x1 plywood and glue. These two tubes, which enter either side of the collision chamber, are the final stages of the primary accelerator ring which circumnavigates the entire test site. Here we have a loading chamber to enable the loading of subject A, and here is the other for subject B. This is a high-definition relay screen to show us what is happening inside the collision chamber at the moment of impact. Very sophisticated sensors located within the chamber will track the trillions of particles that are emitted and relay this data to our analysis servers located in the control center external to this site. This information will take approximately 30 to 40 seconds to collate, and the final result will be relayed back and displayed on this screen. We will then know whether the experiment has been a success or failure. We shall see. Okay, let's fire her up. Higgs, situation report.
In plant state beta, sir. Course to steer by SINS 090, Part 19, about 23 are available. We are fully charged on all tanks, sir. The collider is on prime with empty accelerators and empty chambers. Higgs on the helm, sir.
Very good, Higgs. Final temperature readings, please.
1.97 degrees Kelvin, sir.
Excellent. Bring her up to plant state alpha over 1 minute. Open loading interlocks. Initiate coolant boosters in secondary and primary accelerators. Set containment state to full lockdown. Contact the control room. Confirm codec lock and set data lines to send and receive.
Interlocks and potters released. Ambient temperature and accelerators decreasing within SOP thresholds. Awaiting confirmation of containment state. Codecs transmit and receive are stable. Control room are on standby, servers are spinning and awaiting data. Confirmation received. We're in full lockdown, sir.
Very good. Higgs, monitor coolant levels and containment. Opening loading chamber A now. Subject is in transit. Placing subject into acceleration ring. Closing loading chamber A. Safety mechanism A reads safe. Opening loading chamber B. Subject B is in transit. Placing subject B into acceleration ring. Closing loading chamber B. Safety mechanism B reads safe. Now removing safety cotters from A and B loading chambers.
Arming is indicated, sir. Loading chambers are fully armed, sir.
Increase velocity in primary ring. Slowly, man. Slowly.
All systems are stable and within threshold, sir. System is indicated ready. Please initiate firing sequence.
Final readings.
All readings are indicated within threshold.
Stand by to release subjects into the acceleration ring.
Standing by, sir.
Release on my command. Now.
Subjects away.
Time to impact.
20 seconds, sir. 15 seconds, sir. 10 seconds. This is it. 5, 4, 3, 2, 1.
Higgs, this is unfortunate. Bring all systems down to plant state beta and reinstate open containment.
Yes, sir.
I think I can speak for everybody present here that this is a disappointment to us all.